Hello, my dear students, energetic students, joyful students. The journey was so much of fun so far, and we have learned so much. And this is the last mile where we're doing a lot of PYQs. And today we'll solve three questions from 2022 paper. I would like to introduce briefly about me, a little introduction. So my name is Bhavdeep Sethi, and with a passion of teaching physics, I have converted so many physics haters into physics lovers. And I always say, go out in nature, learn physics that way. Now, obviously, you should never expect spoon feeding in any of my classes, including this one. So the exam is scheduled on 24th of November, and this is the time when we do a lot of PYQ. So let's jump into it. So the very first question that we have here says, simplification of a kind of interlock is simplification. Okay, maybe, yeah, sure. All the surfaces are smooth and frictionless. The body mass, this one is 1 kilogram, this tiny body, and the bigger frame here is 15 kilograms. It says the time that this mass m takes to reach the base there, assuming the height here was 4 meters, is how much? Use gravity as 10. Very easy question if you visualize what's going on. So what's going on here is this starts to come down, but to come down, it has to pull that string. So visualize this way, that if this were to move 1 unit there, think about this. If this were to move 1 unit there to the right, this would release 1 unit of thread here and 1 unit of thread here. So overall, when this moves 1 unit of right, it releases 2 units of threads that is available for this to come down. So what would happen is, if this is moving right with acceleration a, this is coming down with acceleration of 2a. What about the forces? The force on this frame is this tension T. So let's start writing it. So let's say there is a tension of T here. So there's a tension T here, and then there is a tension T here. So overall, it is getting a tension of 2T. But think about this, it is pushing this tiny little mass to go forward. So there are forces involved here, the normal forces. So this block pushes the frame backwards with some force, let's call it normal force N. And similarly, this block would experience a normal force N there. So if we were to draw the free body diagrams, they would look something like this. So for the frame, you would say there is a tension here, and there is a tension here, and there is a backwards normal force. This is the free body diagram of this frame. And with this free body diagram, it's moving forward. So I can say 2t minus n is providing mass times acceleration. Acceleration is a, mass is 15. That's my equation here. I do not know t, I do not know n, I do not know a. There are three variables. I need two more equations. So let's go for this block here. So this block in the vertical direction has a force of mg. M is 1, so I can simply write g there, and then there is a tension force going up. But note, it is going down with 2a downwards. So I can say g minus t is 2a times the mass. Mass is 1, so I'm not even writing that. It's 1 kilograms, right? Now in the horizontal direction, there is a force of normal n and acceleration of easy, because this force n is equal to ma. M is 1, so normal force is a. So three equations, three variables, piece of cake. Now so n is a, you plug in a here, you plug in a, this becomes 16a, so tension is 16 by 2, which is 8a. So this equation implies tension is 8a. You take this 8a and plug it in here. G is equal to 8 plus 2 is 10a. So A is equal to G by 10. But they're saying take G as 10. So A is 1 meter per second square. Okay. The goal of this question is to find what time will this take to fall down. But if the acceleration is 1 here, that means this has an acceleration of 2 meters per second square. It is starting with 4 meters of height. So F equals ut plus half at square. So 4 equals ut is 0. Half times acceleration is 2 times time square. 2 cross out, time is 2 seconds. And such a beautiful question out there. Okay, let's move on to the next question. I like this question. Again, I like the questions which are simple, but there's a deep understanding involved when we do those questions. So a number n of identical balls of each having mass of m and radius of r are stringed like beads at random and at rest along a smooth, rigid horizontal rod of length L. This is length L, okay, mounted between two immovable supports. R by L, as in the radius of these beads or balls, divided by L. I mean, they're small. They're very small, but not negligible. So they're small enough, but not zero dimensions, right? So yeah, they're not point objects. Collision between the balls and between ball and supports are perfectly elastic. One of the balls is struck horizontally so that it acquires a speed of v, resulting outward force felt by the supports averaged over a long period of time. Beautiful question. So question is easy, but there are a lot of things to understand here. See, what would happen if you give velocity v to this? This is mass m, mass m, mass m, m, m. Everything is m. Two identical masses, 100% elastic collision, they exchange velocities, right? They exchange velocities. So this collides with this, it has a velocity of v, it has a velocity of 0. They exchange it. What would happen? This would come to rest here, and this will move with v. This moves with v, it collides with this. This one comes at rest here, and it takes v. This takes v, this takes v, and then it strikes, and then comes the return journey. Even that collision is elastic. So it strikes with V, returns back, then tick, 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 tick. So things are just moving, but eventually they're not. This one takes this position, this takes this position, and so forth, and the last one strikes there and regains back its original position. Such a beautiful thing. And then on the return journey, when this has taken this position, this strikes back here, and then same thing over and over. So, from one of the pillars perspective, think about it. When this hits back and goes back, there is a change in momentum of 2mv because it's 100% elastic. mv minus mv. So there is a change in momentum of 2mv with each collision with each of these pillars. Now, what is force? Force is the rate of change of momentum. This is the momentum change. In how many seconds will this happen? So what would happen is this strikes here, then goes, and then comes back, strikes again, goes. So how long will this bead take to go and return back? On an average, the distances are different, but think about everybody is taking the velocity of the previous one. So whenever there is a motion, one of the beads is moving with the velocity of v, and overall there is a v going there, v coming back, and the time taken would be the distance traveled by the time by the velocity. Now, how much is distance traveled? The length is L, but wait, these are not point objects. So the length is L, but then you got to subtract the part that the space they're taking up. Each bead is taking up 2r, the diameter, 2r. So n beads would take up 2r times n. So minus 2r times n. So this is the length available for that movement. And that length available for that movement divided by the velocity, this is the time that you got to plug it in here. L minus 2Rn divided by V, so that jumps up and that is your answer. Beautiful question, isn't it? Okay. Let's go to the next question. A cylindrical tumbler of diameter D has smooth sides and smooth edge. A thin rod of length L is balanced on the edge of the tumbler as shown in figure. The angle alpha that the rod makes with horizontal for the trick to work. Okay, very, very good question out there. So let's write down the forces. First force I can foresee here is some normal force here, N. Okay, making an angle of alpha. So this angle would be alpha between those two. So the vertical and that, there is an angle of alpha. Now another force here I can see here is mg acting at the midway over there, mg. So they're saying, okay, how much should be this angle? Now I know the body is in equilibrium. So all the forces should balance out, all the torques should balance out. Now one more force there is, which I did not mark here, is this green force. That would be this normal force. Let's call this N1, right? That would play no role. I can show you how. Because see, my strategy here would be, I would like to balance out forces in this direction. Because I know mg, then I know this normal force as a component of n cos theta. They have to balance out. This would not come into picture because this does not have any vertical component. And then secondly, I can say, what if I balance out the torque at this point? So again, N1 will not play any role. So let's start with the first one. I'm saying in the vertical direction that N cos theta or N cos alpha, to be more specific, is equal to mg. There's no third force here. Talking about the torque about this point, this plays no role, but this n times this distance, how much is this distance? Simple trigonometry, come on. If this is d, this is alpha, this is d divided by cos alpha. So I'm saying n times of d divided by cos alpha should be equal to, so this is the clockwise torque, should be equal to anti-clockwise torque of mg times this distance. Now think about, this is midway, this is L by 2, L by 2 cos alpha, isn't it? This is L by 2, and then this distance would be L by 2 cos alpha. So that should be equal to mg times L by 2 cos alpha, and that is your almost the solution. They're saying how much should be alpha. Then you can see in the alpha, mass is nowhere coming into picture. Normal force is not coming into picture. So you can take mg, plug it in this here, or you can divide these equations. It's one and the same thing. So I would rather say instead of this mg, you plug in n cos alpha here. So you get nd over cos alpha is equal to, you get n cos square alpha. So I'll write it in a little legible kind of thing, right? N cos square alpha L over 2. Now I can cross out this normal force as well. So this becomes cos cube alpha. So 2d by L is cos cube alpha. So let's write down. So cos alpha would be 2d by L to the power of 1/3, isn't it? Because cos cube alpha is 2d by L. So how much is alpha? Alpha is arc cos of all this, arc cos of all this. I can see the answer over there. See, this is what you should be doing at the last lab. You should be trying out these PYQs, and this will boost your confidence. It's not a very difficult exam. It is, yeah, it is made up of a mix of easy, medium, difficult questions. But you got to do your time management. You don't want to spend too much of time on difficult questions. So if you like this, please like the video, subscribe to our channels, send this link to your friends, motivate them to subscribe also. Now, if you need a paid course, that many of the students actually contacted me on Telegram saying, sir, when are you starting the Achievers batch? We are starting it now. So we are starting NSEP Achievers, the final lap batch, which is starting on 8th of October. We'll be having PYQs, all PYQs, lot of PYQs and challenging PYQs. So the classes will be every Tuesday and Thursday, 6 to 7:30 p.m. The last week, the week of your exam, we'll have class on Monday, Tuesday, Wednesday, Thursday, Friday. And the test will be every Sunday, incremental test. So whatever you study for the first 3 weeks will be in the third week exam, first 4 weeks on the fourth week, and so forth. So there will be 5 part tests like this and one full test on November 23, the right one day before your final NSCP exam. 15 live classes, 6 tests, assignment after each class, doubt clearing on Telegram. The price is only 2222, but hold on, please hold on. So you apply the coupon code BSPRO1, BSPRO1, the digit 1, you get 10% discount. 10% off. So this price will not be 2222, it will be 1999. It is for all the students of 10th, 11th, 12th grades. But if you are targeting next year, so this is the coupon code. But if you're targeting for the longer term, like next year's NSEP, you can join Full Physics Mastery 2025, which has been divided into 5 modules. And we go slow and steady, and we do a lot of in-depth study over there. It has been divided into 5 modules, and the course is in the middle of it. So you don't have to pay the full fee. You can pay part fee for the whatever modules were already over. You don't pay the fee, but you get the free recordings of those. So the links of all these courses are in the description box. So feel free to use the coupon codes out there. And obviously, what you need for joining these courses is willingness to learn, commitment to hard work, and your full Josh. And like we have been getting a lot of medals out there. So Dhruv Shah and Aditi Avnish, I mean, they have been getting medals at international stage. So I look forward to you in one of these classes. Always keep up the high Josh. Josh is the key. So bye.